So today's note should be a review. I shouldn't be teaching you new stuff today. This should be things that you've seen before. Again, should and how much you remember is gonna, depend on years past, but should have seen it before. So 2.7 is about inverses. By the end of the day today, hopefully before the end of the day today, hopefully by the end of the hour, right? We are going to be able to find inverse equations. And evaluate real life situations. Okay, so the way that your book describes it, of how to find the inverse, is over here. In my mind, it's a more two-step process. So I'm going to translate what they are saying into Miss Bethel language. So here's your translation. I think of it as 2 steps. Step number 1, switch X and Y. And they kind of say that right there, but bless you. Step 2, again, to me it's only a 2-step process. Step 2 is to solve for, and I call it new Y. Because if you just switched X and Y, a minute ago it wasn't Y, right? It was X. So I call it solving for new Y. So in Miss Bethel land, this is how I think about it in my head. That I'm going to switch my X and Y, and then I'm going to solve for new Y. Again, new Y because a minute ago it wasn't Y. Alright. The other thing that I want you to remember about inverses, and this is even maybe a way that you could check your work, is that if you look at inverse graphs are a reflection over the line. Does anybody remember which line? Y equals X. If you're guessing like X or Y axis, you can see why you guess those. It is a reflection over the line Y equals X. So think about Y equals X. That's your oblique line that comes up and cuts through your graph. So that's why I wanted to steal a calculator from someone, because my husband took my calculator out of my pocket. So keep these at home. Anyway, I want to show you though that what the graphs look like. So it's a way to check your work and see, like, are these things truly inverses of each other. Alright, so we're going to do 4 examples. We're not going to do part E because E and D are very similar, and I just feel like D gets if we can see what's going on, and we don't need part E. So I'm going to do 4 examples because they're all a little bit different. Alright, first of all, f of x is a fancy way of saying y. So y equals 6x minus 8. Remember the 2 steps we talked about. We're going to switch x and y. So x equals 6y minus 8. And now I'm going to solve for new y. This is new y to me because a second ago it was x, right? And now it's y. So I'm going to solve for this new y right here. And again, solving means I'm going to isolate. I'm going to get everything else moved away from it. How can I get rid of the minus 8? Add 8. So x plus 8 equals 6y. Then what? Divide by 6. The 6's cancel. So y equals x plus 8 over 6. Now, you don't need to find the domain. There's nothing else that you need to do. Like, this is your final answer here. Okay? Now, the other thing that you're probably going to see in your book, though, so I want to make sure I tell you, is that instead of writing it as y equals, your book typically tends to use the inverse notation, where it's f to the negative 1 of x. So that means inverse. So if you ever come across this notation anywhere in math, it always means the inverse equation. So we've got x plus 8 divided by 6. Flush. Now, someone in second hour said, if I leave it as y equals, is that okay? Yes. I just want to make sure that I'm showing you this notation as well. So if you had y equals x plus 8 over 6, I would still give you full credit for that. Okay? I'm not quite that picky on this part, but again, I want you to know what that notation means. Alright, so f of x is a fancy way of saying y, so I'm going to write a y there to remind myself. I'm going to flip x and y right away in this problem, so x equals y to the 7th minus 7 over 6. So we need to start strategizing of how we can get y alone. So the first thing I think I'd like to do is get rid of the fact that it's a fraction. Agree? How can I get rid of that 6 in the denominator? Yep, let's multiply by 6. So 6x equals y to the 7th minus 7. Those will cancel. Okay, still trying to get y by itself. What can I do to help isolate next? Add 7. That's what I would do too. Again, you can go different orders, but depending on the order you go in, it really can cause some trouble and make it a trickier problem. So this is really the order that's kind of the path of least resistance. How can I undo the y to the 7th? 7th root each side. So I'm going to 7th root this side and this side. Remember, when we're solving an equation, which is what we're doing, right? We're solving for y. We have to keep both sides balanced. So if I do something to one side, I also have to do it to the other. So I have to 7th root both sides. Do you remember what I have to do that's kind of tricky if it was an even root? Yes, thank you. I would have to put a plus minus out front. So if this had been a 6th root, or a 4th root, or a square root, when I go to solve, I would have a plus minus sign out front. This one I don't, but normally I would. So what's my answer? Y equals the 7th root of 6x plus 7. Again, I'm fine with you leaving it like this. Can you write it with a proper notation? Sure. Okay, next one. This is y. Let's flip. X equals the square root of y minus 6. I want to get y alone, but it's problematic that it's under the root, right? How can I get rid of the root? Square it. To undo a square root, we need a square. X squared equals y minus 6. Now what? Add the 6 over. Okay, so let's take a look at this one really quick if I were to graph it. So I'm going to graph both equations. I'm going to go to y equals, and I'm going to graph the square root of x minus 6. And then, hold on, I'm going to turn down the brightness real quick. I'll tell you how to turn it back up in a second if you want it super bright again. The other one is x squared. Actually, I don't want to do this one. This one's going to look a little funky because we need, I'm going to do the other one. I'm going to do this one. Okay, just kidding. Sorry, false alarm. I'm going to come back to this one and just show you how to check your work. So I'm going to hit 7, math. I'm going to come down here. I'm going to do 6x plus 7. So that's one of the two. And then I'm going to do the original equation, which was x to the 7th minus 7 all over 6. Okay, so those are my two equations. Let's take a look at the graphs. Okay, you see both of them? Watch what happens when I put in the line y equals x. Are they reflection symmetric to each other over the line y equals x? So that's a way to check your work and make sure, if you hit second up, it'll get brighter. If you hit second down, it gets darker. Yep. So that's a way to check. So the reason I didn't do this one is because it would only graph one part of it and it wouldn't look quite okay. This one's better to look at for an example. All right, next one. Y equals. Let's flip x and y. What do you notice is a little bit more problematic about this one than the other? There's 2 y's. Alright. Okay, so the first thing that I would do is I can't solve for y if it's in the denominator of a fraction. Like, that's a problem in and of itself, beyond the fact that there are 2 y's. So the first thing I'm going to do is multiply each side by 3y plus 1. On the right side, do you see how these would cancel? So I'm left with 4y minus 2. On the left side, it is actually going to help us to multiply it out. I know sometimes it's helpful, sometimes it's not. This is a case where, yes, I'm actually going to multiply through. So this is going to give me 3xy plus 1x. Okay, we want our y's to be together. Agreed? So I'm going to subtract the 4y over. And at the same time, I'm going to be time efficient here. At the same time, I'm going to subtract the x to the other side. So I'm moving stuff around so that my terms with y are together, but alone. And then my other stuff is on the other side. So these will cancel. I get 3xy minus 4y. Can I actually subtract those? Are they like terms? No, because one has an x. And then on the other side, this cancels. I get negative 2 minus x. Or you could flip them. Last hour I wrote it as negative x minus 1. All right, so your strategy here is to take a y out. So we're going to factor it out of the left side. So if I take out a y, because they each have one in common, I get 3x minus 4. Follow me on that step? The benefit of taking the y out is now, do you see how it's kind of isolated out front by itself? How can I get rid of the parentheses? Divide it back away. So again, if I wrote it with my notation, x to the negative 1 of x equals negative 2 minus x over 3x minus 4. And that would be my final answer. Again, we're not working with domains on this one, so we don't need to think about where the undefined. Move that up a little bit in case people in the back can't see. Is that good? Okay. Flip when you're ready. We're going to do a little bit of the application problem that's on the back page. We're not going to do the whole thing. We're going to do part A and part B though. Alright, we've got a commodity that we're selling. A commodity is just anything that you go to the store to buy. Okay? Could be like could be anything. So a commodity is a good that you're going to get. Our equation is that the price or the cost for the commodity is equal to negative 3p plus 150. We want to calculate the inverse equation and also think about what that inverse equation means. Now, when I go to calculate this equation, I'm going to rewrite it in terms of x and y because that just works better for me. Remember, anytime you have your function notation, that's just a fancy way of saying y, which means that my p in this problem is like my x. Now that I've got it changed, is it easy for us to find the inverse? Okay, let's find the inverse. So I want to switch x and y. How would I get y alone? What do you want to do first? Yeah, I would subtract 150 as well. Could you divide by negative 3? Sure, but it's going to make it a little bit more challenging. Then what? Divide by negative 3. So x to the negative 1 of x equals x minus 150 over negative 3. And so let's actually flip back to d of p. So I'm going to erase my f, and I'm going to put it back in d. I'm going to erase my x, and I'm going to put back in the p that was there originally. So I'm kind of going back through and doing substitution again, where I'm subbing back in for the letters that were there originally. Alright, so what does this mean? This is actually now set up that it's going to give me the price of the commodity. So think about cost and demand. If something is in demand, could I continue to charge more and more for that item? Okay. So this is looking at the relationship of cost and demand. So originally, I was finding the total value that I was spending. But now, when I move this around, I'm looking at what is the price associated with demand. So that's what this is asking. Okay, so this is giving me the price associated with the demand. So what should I charge for something depending on the demand of that item? So let's plug in 30. It wants me to plug in 30 and see what happens. So if I plug in 30, 30 minus 150 over negative 3. So that's going to give me negative 120 over negative 3. And then I get 40 when I divide. So that tells me that if I'm looking at my item and I have this current demand, that the price I need to associate with it is going to be $40. So each item, each commodity or good that I'm selling, the price that would work and make sense based on our equation is $40 as a ticket price. Does that make sense? Okay. So I'm going to stop there. I'm going to leave this up on the board if you're still writing.